Alright, so this is part 2 of the tutorial. We're doing 1.5 now. Alright, so 1.5, the first question is 1C, 1C and D. So let's say 1C. So for any set A, so A represents a set. So A and an empty set is equals to A. Now I told you, always draw this, right? So A and nothing, right? Picture A with the numbers and picture a set with nothing. Are there anything in common? No, there's nothing in common. A, let's say if A is equals to the sets, let's say 1, right? 1, just 1. And then you have, let's say B set which is equals to nothing. I mean literally nothing. Now nothing will be represented as that, right? Is it nothing? Is anything in there? No. So that's 100% false. Okay, for the next question D, if A, B and C are sets such that A union B is equal to A union C, then B is equal to C. Now straight away you can draw it, right? A union B. So A union B means A or B. So if you're going to draw like a Venn diagram, let's say 1, 2, and let's call this A, right? Then we got B. Now the thing A union B is the same. So that means B has to be the same, right? Because think now if you had to say what is A union B, it'll be 1 and 2, right? Then C, what is it? Okay, yeah, A union C is equals to A union B. So if those two, which is A union B, is 1 and 2, then A union C, A and then another one, then it has to be equal, right? So you can draw it. Because check here. A union B is 1 and 2 is equal to C. You see? And you can, anytime you see this, A or B is equal to A or C, then B has to equal to C, okay? It has to, okay? So the answer there will be true. Now the next one, 2F, okay? 2F. Now 2, okay, this is where it gets a little bit interesting. Okay, 2F. So I did this in a previous set theory videos. I told you, you basically have to break this down. Now, okay, so there's different ways to do it, but there's something called Morgan laws, which you can do it, or you can do it this way. Okay, I'll do it this way. I won't do the other one, because we'll get to that just now. But okay, so not A and not B. So basically, the first one you look at is not A. Not A is everything in B and C, but it mustn't repeat anything in A. So if I say not A, it will be, it'll be 3. It won't be, it'll be 3, 7, 3, 7, 3, 7 and 8. Yeah, 3, 7 and 8, I'm sure. 3, 7 and 8. Because it mustn't be anything in A. 8, perfect. 6, no, it's in A. 3, yeah, I got that. 1, that's in A. 7, I got 7. 5, that's in A. 3, I got that. 2, that's in A. Perfect. So this is not A, okay? Now, oh wait, which question were we doing? 2F. Okay, so not A and not B. So what is not B? Now we finished do not A. Let's do not B. We're not looking at the sign yet. We're just saying not B. So not B will be anything besides this. So it'll be not B. It'll be 1. All right, that's 1. It won't be 3. It'll be 6. It'll be 6. It'll be 8. And then 1. Yeah, we got 1. 2. No. 5. No. 6. Yeah, we got that. Perfect. So this is not B. So now they're saying, now you look at this, okay? Right, this and. So basically saying what repeats? Over here and 8 and 8. Perfect. So now we got this whole answer here for this, right? Now A, not A and not B is equals to 8, right? Is equals to 8. Now when you need to get marks in the exam, so now below this you need to like write what's not A and not B is equals to 8, right? The next one is or C. So or C means just take 8 and add it to C. So it'll be 1, 3, 6 and you already got 8. So it'll basically be equal to C, which is 1, 3, 6, 8. So that's the answer, right? It'll be 1368. The whole answer for this will be 1368. Okay, so looking at it back, I made a mistake. I forgot to look at this where E, which is the universal set, is 1. So basically, if you got like A over here, alright, A, the universal set, right, includes everything in this whole rectangle. So maybe you'll have a number that is outside in not of the sets, right? That is not even in that set. So that will be 1. So that's why over here you will see you have it's 4, right? It's 4. So that 4 is like out of the sets, right? So basically you have to add 4 over here because we said not A. So 4 is not an A. And then not over here. So looking at it, it'll be 4 and 8, 4 and 8. So that is common. So 4, 8 will be the answer to not A and B. Then O, C, you add 4 and 8 to not C. So it'll be 1368 and 4. So that will be the answer, 1368 and 4. Just that I forgot to see this. Basically, number 4 is outside the set. So you get the Venn diagram. You get the Venn diagram. You get a circle here. Get a circle here. And then whatever is outside of here, it's still part of this whole set. That's why the whole thing is called a universal set. You see, so I forgot to see that. Okay, the next question, 3G and then H. 3G, 3G, G, 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 G. Perfect. Okay, so 3G. Now 3G. What is not A or B but not that? Okay, so firstly, not A or not B. Okay, not A. Okay, so first of all, what is a not A, right? So 13AB is A. So basically you need to find what's in not A. So just look at the universal set because this includes all the sets in what you're looking for. And just see anything that has an A, don't repeat it, right? Because everything in here is there and everything in here is going to be there. So if you're saying not A, just ignore all these in there. So it'll be 13AB, so ignore. So universal sets will be so not A. We're looking at not A will be it'll be 2 4 5 CDE. Okay, so this is not A. So not A or B. So B is this whole thing here. So you just add it to B, right? So 2 4 5 CD, and then we got E over here. So you just add it. Okay, so 2 4 5 CD, you add it to this 2 4 5 CD. I mean, it's the exact same thing over here. So that's that, and then not that. So basically now we got this, right? So now we say okay, not that. So you go to this where all the sets are listed, and you just strike. So not 2, not 4, not 5, not C, not D, not E. Right? So the answer will be AB 1. So 1 AB. So that will be the answer, right? 1 AB. And 3. There's a 3 there. 1 AB 3. Yeah, 1 AB 3. Okay. So 1 AB 3. Perfect. Okay, for the next question, etch all the subsets of A. Anytime you get this question, there's only one answer, and you use a formula called 2 to the power of n, right? No matter what, you'll get the answer with this, right? 2 to the power of n. Now, there's lots of subsets this thing has, because if you think about it, sets A, 1 can be a subset of this, 3 can be a subset, A can be, B can be, then 1, 3 can be, then 3, A can be, then there's too many. So, to do a formula, it's 2 to the power of n, where n represents a number of elements in that set. So it's 1, 2, 3, 4. So 2 to the power of 4. 2 times 2 is 4. 4 times 8. 8 times 8 is... No, wait. 2 times... Wait, I'm bad at simple maths. 16. 16, isn't it? Yeah. 2 to the power of 4 is 16. So therefore there's 16. Right? So that's the final answer. There's 16. So remember, 2 to the power of n. Where n is how many elements? So there's 4 elements, 2 to the power of 4, that will be the answer, which is 16. So there's 16 elements. Now the next question, okay, we did that, so it's 2f, we did that. Alright, so 4O and R. Now 4O, let's see, 4O. Okay, yeah. So XOR, then Y and empty set. So I told you break it up, right? So now you got no numbers like this, right? Now you basically have to know, like just know it in your mind what's happening and how to solve it, right? Okay, so firstly, the first thing you need to know, let's see. Okay, so X or Y. Okay, so first of all, this thing in the brackets, that let's see if we can simplify it. They're saying here one intersection empty. So think about it. There's nothing in common between an empty set and any set for that matter, even Y, any set, right? There's nothing. So technically, this whole thing over here can be simplified as just an empty set, right? Because there's nothing that is common between Y and something nothing. You know, Y and nothing, there's nothing common. So it'll be X union nothing, which is the empty set. Right? So and X union nothing, X or nothing is just X, right? Because think about it, X or nothing. So X plus 0 is X. So the simplified version will be X, right? X or nothing. If you get X, right, and you're adding nothing, it's just X. So if you look at R, it's very easy, right? The first part, X UI, X union Y is basically X or Y. It means everything, right? You add everything in X and Y. And then now union not X. So just add not X. But think about it. If you're just adding not X to X union Y, it's the same thing. It's just the same thing as X union Y. Because, I mean, if you have a Venn diagram, okay, let's say X and Y, and they're saying, let's put numbers in here. 1, 2, 3, 1, 2, and 3. X or Y is 1, 2, and 3. Then add that to not X. Not X is Y, so it's 1, 2, 3, 3. Now we can't say double, so it's 1, 2, 3. So it's the same thing as X or Y, you see? So draw it and see what it is. So obviously we add that to that. That already has it in there. So it's X union Y. Now if you look at the next one, it's S, right? So what S says? S says X or Y and X and Y. Now think about it very carefully, right? X or Y is talking about everything in X and Y, right? Everything. You're adding everything over there. And then what's common between X and Y? So what is common between the intersection and that whole set? It'll be X and Y, because think about it. If you have to draw it, draw this, and let's say this is intersecting over there. Let's say you have here 3 and you have 1, right? This is X and this is Y. X and Y, right? So as you could see, okay, let's add another number, you know? Let's say 10. So 3, 10, and then 1 there. If I say what is Y or X, that'll be 1, 10, and 3. Now if I say what is X or Y, yeah, it'll be 1, 10, and 3. Then if I say what is X and Y, it'll just be 1, right? So what's common between 1 and X or Y, which would be 1, 3, and 10? There'll be 1, okay, because that's common between this, because only 1 over here and 1 in the X or Y. So therefore it's X and Y, right? So if you think about it, that's the answer, only X and Y. Okay, the next one, 5, B, and C. So B, suppose X and Y are sets and X and Y is equal to X. What can you deduce about X and Y? So if you think about it, they're both equal, because let's draw it, right? Suppose X and Y is X and Y is equals to X. So X is common. Okay, so let's draw it. Now if you test it out, if you make X equals to 1 and Y equals to 1, which are sets, and that means 1 will be in between, and therefore X is 1, Y is 1, and X and Y is 1. So therefore it makes sense. So see, so they're both equal. So if X equals to a number, Y is equals to a number, X and Y will be the same number. So therefore you can conclude that the set X equals to the set Y. Now the next one, if A and B are sets and A and B is equal to A or B, what can be deduced? It can also be deduced that A is equal to B, because think about it. A and B like this is 1 and A or B is 1. So it's the exact same thing rephrased. So basically they're trying to tell you that If they have one set, they equal. Okay, so part 2 will be out as 15 minutes is reached.